Thank you. Good morning, everybody. Everybody awake? We'll try to keep it that way. Let's see. Because I will try to do some stuff live. Probably stuff will fail, so you can be entertained. Let's see where we can take this. Oftentimes, this is us. You don't have to raise your hand if you think this is you or your application. Just think about it yourself. And for a long time, you often say, oh, this is all fine. And at some point, you figure out, oh, this is no longer fine, and everything is on fire. And basically, the idea is we don't want to get there, at least not the lower half, basically. That's what we want to avoid. So how do we avoid that? The first thing we want to do is basically we want to monitor all the things to figure out that stuff is burning before we are actually on fire. So how to do that? I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats, commonly referred to as the Elk stack as well. I'm part of our infrastructure team, so I do stuff like internal tooling. And then my official role now is a developer advocate, but nobody knows what an advocate is. And I always use this avocado because it looks much more friendly. I just do stuff, demo stuff, try to know stuff, and help out the community. That's pretty much the idea. So I build highly monitored Hello World applications. And today is no exception. We'll use the Hello World of SilverStripe, basically. So it won't be a complex application, but we'll try to monitor that from every possible angle. And we'll try not to cheat too much, so we are using proper certificates, and we'll just see where we can go from there. So how do you log and monitor? Who is using SSH and tail? What is SSH? OK. Or FTP and looking at files or stuff like that? Anybody? Maybe sometimes. Which works. If you have one single site you want to look at, then check if it's working. But if you have more than one site, or if it's getting more complicated, often SSH and tail is not really what you want anymore. Yes, you can do that. Sometimes it's nice for debugging, but to figure out what is really going on with all your systems, it's sometimes a bit annoying. So let's see if we can improve that. So obviously, our application is based on SilverStripe. I actually got started with SilverStripe. I was one of the original Google Summer of Code students. I think that was in 2007. And then I was a mentor some years later. And yeah, I wrote one of the SilverStripe books, which is now totally outdated. And every time I look at SilverStripe today, everything changed. And I'm like, I don't even know what is going on anymore. But it's probably the same for everybody, too. You need to constantly upgrade stuff. Yeah. So I want to run my demo on the cloud because, well, everybody runs everything on the cloud today. I'm using the cheap AWS instances. I have set them up with Terraform automatically and then just roll out and configure everything with Ansible. If you're interested in that, I have it in the repository, and we can just talk about it afterwards. But like setting everything up, I kind of skip today. It's like, you know, the cooking shows where everything is prepared, like all the vegetables are already cut. We're doing the same thing here. Like the little pieces are already prepared. We'll just do the monitoring part now. Yeah, we have our own cloud service where I can throw in the stuff to show everything that is going on. So this is kind of the setup that I have there. I have some instances where this is running, but it's not all that interesting. Basically, all I'm showing you is open source. You can just take it, use it, change it, adjust it to your needs, and get going. So this is generally our stack. So Elasticsearch is the component that is probably the most widely known. It's where you store your data. Kibana on top of it is to visualize. That is what you will see a lot in the demo. And the beats are like lightweight agents or shippers. They are just collecting information and forwarding that. They're written in Go, so you have native binaries. You don't need to install the JVM or anything on your servers to collect logs or anything. You just have a small binary that collects different kinds of information. And we'll see the details later on. We also have Logstash. That's more of an ETL tool for extract, transform, load, to get data from various sources, transform it, enrich it, and put it somewhere else. But we don't need that for today. So we'll stick to Beats to collect, Elasticsearch to store, and Kibana then to visualize. I keep it super simple. I have a front-end and a back-end instance. The front-end instance has Nginx and my SilverStripe application, plus some Beats to monitor that instance. And my back-end instance has MySQL another Nginx which we don't need for that demo that much, and some more beats to check stuff. And then we have a central Elasticsearch and Kibana instance where I basically throw all my data to see what is even going on. So let's try to do some things. So I might need to cheat every now and then to remember all the steps that we have. So if you've never seen it, this is Kibana. Just to give you a quick idea what is running here. So we have, I have some Elasticsearch nodes for my monitoring. I have been collecting data for a few weeks now. So there is data, we don't need all that data, don't worry. We have one Kibana instance to monitor that, and we have some beats running. So we have all these beats running here. You can see most of them run on both my instances. Only this one here, this is basically a pinger that is only running on one instance that is monitoring everything. And yeah, they'll just collect things, and then we'll see where this goes. So this is our SilverStripe site. We'll get back to that in a moment. First off, let's start a bit lower level. Let's see on the system level what my system is up to. I want an overview, and let's say we want a system overview. Metric beat, system overview, that's the one I want. So basically, this just shows you what you have in your system. So we have two instances running. Sorry. We have some CPU and memory usage. We see disk and, well, what my instances are up to. You can also see like a flame graph of the CPU usage, but that's like 2% or so it's really low and not much is happening here. You can also dive into one of these instances. So for example, if I go to that backend instance, it will show me just the details of that instance. This is pretty much like what you get from top. It's just running continuously in the background, and is collecting that information so you can graph it out. So these are the last 15 minutes, but we could also change that to the last 24 hours or whatever. And then you can see something is happening here. We have these, like the red area is the memory we're using. And this is basically a spike because something is happening here. You can also aggregate it over all the instances to see how that looks like. Okay, the spike is a little less, but something is doing something weird on my instances. And that's the first thing I kind of want to figure out. Like, what are my systems up to? What is the resource usage? So for that, I want to build a quick visualization myself, because the dashboard I've just shown you, that is pre-built. So I'm lazy. You can be lazy too. You don't have to build that yourself. You can just use that. But now to dive in, I need to build one visualization myself. One that comes in very handy here is the visual builder. What that one is doing, basically, you have a time axis, and then on the y-axis you have some events. And you can see right now it's just a count of documents. So I'm storing around 100 documents every 10 seconds here. What I want to see is, I want to see the memory use here, actually. So instead of a count of the documents, I want to see the sum of one specific field. And this field I'm interested in is something called system memory. And yeah, we support Docker and Kubernetes, but I'm only interested in system memory actually used bytes. And once again, you can see the spike. And the first thing that you see, then it's just a big number. It's not that nice. So in options, I want to switch that over to bytes. So if I hover over it now, you can see, okay, here we spike up to 1.4 gigs of memory. Generally, we only need about a gigabyte of memory. But every now and then, we jump up here. So let's see which instance is that. So I can break that down into the instances to see which instance where my stuff is happening. So I can break that down. I just have the instance name in a field called beat name. I break that down, and you can see, okay, the front-end instance is super stable. The back-end instance is not so much. And then I add a second visualization to actually see which processes are causing my spikes. No, this is not the one I want. This is the one I want. Here, let's say, and this is system memory. And here, once again, I want to have a field, and we have a field called system process memory RSS bytes. This is what contains how much memory every process is using. So we just need to break that down into a field called process.name. Let's say we want to have the top 20 processes based on this amount of system memory. It's kind of stupid to see because it's one over the other. First, let me switch over the color here. And secondly, let's put that on the negative y-axis. So basically what I'm doing here is I'm doing a calculation and I'm picking my variable here. Let's call that RSS. Oops. And then I can access it with params.rss times -1. So basically, we want to take this value here and put it on a negative y-axis. So then you can see positive y-axis, this is the system memory, negative y-axis, these are the processes. And then you can see we have a spike. Any guesses what that process might be? Backup? No, it's not a backup. It's Java. Which is totally unrelated to our project initially, but I always explain it like this. This is kind of like the typical Java process that is running somewhere. It just consumes memory until it dies with an out-of-memory exception. And this one here, I call it the bad jar. So what the bad jar is doing, it's being run by a cron job every 5 minutes, and then you can see this spike. So it's not doing anything useful, but you can still figure out what stuff is happening. So let's stop the bad jar. I have this one here. I want to disable it. So yeah, this is all automated in Ansible. Basically, I run the bad jar, and then it runs every few minutes automatically. I just disable it now. Let me quickly run that to disable it. We might come back to that view to see that the spike will be gone afterwards. By the way, one other nice thing is whenever I run this, at the very end, I store an event, also in Elasticsearch, to store that I have changed something. So since I only change my system in an automated fashion, I can store that somebody changed something in the system. And that will be very handy to see what has been going on. So here we have these annotations, and in the annotations I can basically say I think it's called events, if I'm not mistaken, and then I have 3 fields that I want to show here, which is user, application, host, and then I can basically say here user changed application on host, or let's say ran. And then you can see this annotation here, and then basically you can see that I changed something on the backend instance with this Ansible script. And that way you don't have to run around the office anymore and shout like, who changed something? And what did you do? And why is everything different now? Because it's all automated, and I can just have these structured events. And afterwards we'll just let it run in the background, and the spike should be gone from now on. And you can see, okay, I deployed a new version, everything got better, or sometimes everything got worse, and then you at least know what to roll back. Anyway, let's head over to our application. So I need some requests. Everybody get their laptop or phone, please, and get some requests to this. By the way, does anybody know how I came up with this name? Sorry? No. So this actually has something to do with my name. So this is my Twitter handle, and .wtf for the domain makes sense, I think, for a demo. So what could be the relation between this and my name? Or more specifically, with my last name? Yes. Yes, this is the good old ROT13, where you basically change the letters by, you kind of go 13 letters further in the alphabet, and then you get from Krenn to this. And the nice thing about the ROT13 is, if you run it again, you're back at the original, because, well, 26 letters in the alphabet, changing it by 13 twice, this is where you get. So this is why we get this URL. So basically, you can hit this endpoint, and I guess everybody should be getting a site, right? So let's see what you have been up to. So the first beat that was running, this was the metric beat. So it's collecting system metrics or application metrics. Another beat we have running is the so-called Packetbeep. Packetbeep is basically like Wireshark. Who's using Wireshark? Normally that's a very bad day when you're debugging, right? Because when you need Wireshark to debug some problem, it's really, really not a good day. So Packetbeep is based on the same base library. It's just listening in on the network traffic, and it basically sees your requests and responses, and it figures out, okay, this was the request response. You requested, for example, HTTP, you got back at 200, and it took 50 milliseconds until you got your response. So generally, Packetbeep is just using libpcap, running in the background, and we can see, okay, you started doing some requests here, so we got a spike in requests here. Well, they also caused some MySQL queries in the background then. We don't have a cache or RPC system. Here, the height of the bar basically shows you how many requests and the color if they were successful or not. You can see stuff like a latency histogram or errors or OK. Let's make OK green, but this is randomly assigned, so you never know. Luckily, we didn't get any errors. You can see, okay, somebody had some TLS issue, and then you see a latency histogram. So 4,500 requests were fast, but somebody had to wait 760 milliseconds for some data. So you basically see this is generally what is happening with our site. We also have some TCP IP information. This is what we call flows. There we can just say, okay, these are the number of connections we have to our system, for example. And you can see which IP addresses are communicating with who. It's just fancy graphs. We also have web transactions, but those are pretty much empty, unfortunately. Or not totally empty, but you don't see that much. Because you see, okay, we have some gets, and then we can see we had mainly 301s. Why might that be the case? So you can see all of these requests were 301s. Why don't I see any real traffic? Well, we're doing the right thing. We have everything encrypted, and if it's encrypted, we cannot see into the application. So that's kind of unfortunate. But we have that information somewhere else. Any guesses where that would be, or where I should start looking? Sorry? Come again? Yeah, so basically the information I want to check out now, or I'm using Nginx, but Apache would be the same thing. So if you go to the access log, and in here you can see you have a lot of useful information. So we can see, actually this is not the entire line. Here you can see we have an IP address, we have a date, we have a timestamp, we have get the HTTP verb, we see what resource we requested, we can see the HTTP version, the response code, how many bytes we sent, and the user agent. The good old way to get that information was to write the regular expression to parse that information and then access it in a structured format. However, at some point we figured out that everybody, not everybody, but lots of people are running either Apache or Nginx and MySQL, and we could just do the work for you and collect that information automatically. So what we do now is basically you just say, I want to monitor the log files. For that we have FileBeat, kind of obvious. I want to monitor Nginx with FileBeat. And basically what that looks like, just to show you some configuration, basically what I'm saying here is in FileBeat, I just want to monitor Nginx, for example, here. I annotated with some extra stuff, and then I send that information to Elasticsearch. So far, so simple. And we also have a pre-built dashboard for that. Let's quickly head over to that. Here, basically, we have just collected all the information from the Nginx access log. So you can see you started doing more requests. Did somebody start an Apache bench or something like that against my service? Which is totally fine, because otherwise I would need to do it myself. So that's good, so I don't have to do the work. But somebody is generating a lot of requests, which is good, because, well, at least for now, my service seems to be keeping up. You can also see how much traffic we are serving. We can see the user agents, for example. Let's see, iOS, did everybody upgrade their iOS yet? And we can see, okay, the majority is on 12 already, but a good portion of you is still on 11 as well. And all of that is just in the Nginx access log. So you don't even need anything like Google Analytics. You just have all of that information in your Nginx access log, and you can just harvest those. Let's get rid of that filter. We also have this nice little map. Where are we getting that information from? Yes, we do a geo-IP lookup. Sometimes that information is good, sometimes it's not. We'll figure out what it is today. So let's see how close we are. Oh, actually today it seems to be pretty good. But that really depends on the geo-IP data. Sometimes the quality of the data is good and sometimes it's not so good. I think we're somewhere around here, right? So, okay, close enough, I guess. It's not, it's like a few hundred meters off, but generally you get the idea where your requests are coming from. So here you can see we had around 18,000 requests coming from Nginx, which is interesting. Somebody is very interested in our service today here. By the way, one other thing where Packetbeep can be very handy, and I should maybe show that as well, is for TLS debugging. Because everything that is encrypted, you cannot really see into the traffic. But DNS and TLS are things that often make sense to monitor as well, because TLS bugs are a pain in the ass to monitor. You can see, A, how many TLS sessions do you have in general, how many requests did you have, and here you can see when did you have the main cost, or when did TLS add a lot of overhead. So you can see here we had all the handshake latency that we were collecting. So here we were having like 40 milliseconds or so of TLS handshakes. You can also see which version of TLS people are using, which domains. And you can see this is basically a unique fingerprint of the host based on TLS. So somebody has done 16,000 requests, and somebody else has done 180, and everybody else had fewer. So this is just TLS. One other fun thing is, did anybody try to hack my server? Because if you didn't do it, then somebody in China probably did. Let's quickly change that. These systems have been running for some time. So you can see here, this is the auth log for SSH. And you can see these are all the login attempts that somebody made. And somebody tonight seemed to have been very interested in my service. So at 9 p.m. UTC, there were like almost 11,000 failed SSH attempts to my servers. You always have them. Just if you don't monitor them, you don't see that they're happening. And stop using passwords because somebody might be guessing those. You can also see like here, this is when I set up stuff. So I connected myself. These were the successful logins. And down here you can see, A, where did the unsuccessful logins come from? So yes, this time it's China. Sometimes it's Russia, sometimes it's China, sometimes it's Ukraine, you never know. But this time it was China. And you can also see these are all the unsuccessful usernames people tried. So you can see Raspberry Pis and loads of other things that people tried out. It's just nice to see what people are even doing on your system and trying to achieve there. Okay, so since you have been generating more requests for my system, I'm curious now what that means for Nginx, for example. So we saw metric beat initially already when I showed you the system metrics, but we can also do application metrics. For example, we can do, and I always forget the URL I've configured for that. Is it status? So this is the Nginx. These are basically the Nginx statistics that you can expose from Nginx if you configure it accordingly. They are not that many because that is the way that Nginx makes money. If you want to have more detailed statistics and have them in JSON, they have a paid version where you get that data. But this is kind of the minimal set. And what we basically have is we have something that goes to this page every 10 seconds, I think, collects the information and then stores it in Elasticsearch, and then we can graph that out. Just to give you the idea how that looks like, so these were the system metrics we've seen at the very beginning. Basically, we were collecting them every 10 seconds. And now I'm interested in the Nginx module. So basically, I'm collecting Nginx every 10 seconds, the so-called stub status page, just to see what that is doing. I'm also collecting the PHP FPM information. Oh, sorry. This is actually the PHP FDM. This is actually the PHP FPM information. And I think, is this Nginx yet? Sorry, this is the Nginx information. So this is all you get from Nginx. And I'm basically collecting both of them to see what Nginx and PHP FPM are up to in my system. So let's see. We want the metric beat of Nginx. and the last 7 days probably don't make too much sense. Let's switch back to the last 30 minutes when you started doing requests. So you can see here, well, you started working on the system, and you can see these are the active connections. Like you stopped your pinger again, right? Because here you can see, okay, we had a lot of requests here, and now they kind of died off. You can see the request rate. Yeah, the throughput is pretty good. Like every 30 seconds, we did like 2,000 requests or so. Luckily, we didn't drop anything. You can see how many requests we handled. That's also developing pretty well. And you can also see, like, oh, here we had quite a few workers from Nginx waiting, and here it kind of like improved over time again. And we have, by the way, the same thing for MySQL, which also might be kind of interesting. Let's see the overview of what does it actually mean running so many queries for MySQL. So here you can see, okay, it's only read-only, so we don't do any inserts, deletes, or updates. But you can see we were running more than 1,000 SQL queries every 30 seconds. You can see, okay, number of connections, how many threads MySQL was running, opening tables, how much data it sent and received, and how many open files. So this all looks good. We also have for MySQL, we have a module to actually monitor the network, the log files. Let's see if we had any errors. Luckily, we didn't have any errors in MySQL, so there is nothing here. That's good. Will we see something if I show the Packetbeep information of MySQL? Will I see anything, yes or no? Well, it depends. Do I have SSL enabled or not for my connection? I don't remember. Let's see. Obviously, I don't. Maybe I should do that. But since it's in the open, you can basically see which commands you're running. So let's quickly see that here. Nothing, nothing, nothing. And then you started doing your requests, and basically you can see, okay, we have a lot of set operations, we have a lot of shows, we have some selects, and we have a few checks in here as well. And then you can just see, okay, response percentiles, like how long did it take MySQL to respond? So most of them were pretty quick. These are milliseconds, so yeah, up to the 99.5th percentile, so only 0.5% of your queries were slower than 75 milliseconds here. You can also see, like, okay, traffic and which SQL queries you were running the most. If you find, yeah, this is, luckily it doesn't have a wildcard in the beginning, but otherwise this might be, like, anything with like might be an expensive query. So you might just look at which queries are you running frequently and are they optimized and fast. And if they're not, you might want to set indices or just figure out why am I even doing these queries and try to get rid of them. Okay. We can also trigger errors here, by the way. If I remember correctly, there should be error. And we see, okay, something is causing a warning here. I think we also have a client error somewhere. Okay, this won't be propagated to the server side, but this is just some happening client side. And then we have a server error where really bad stuff is happening. How would you go about to collect these errors in a centralized fashion? Well, first off, we're writing them to a log file. So let's quickly see. No. This is actually not what I want. I want less. And then we probably have a SilverStripe log. See, it doesn't like emojis, which is a shame. So here you can see, basically these are the log lines. And so I've basically configured Monolog for logging, and I'm just writing it out as a file. And you can see here you have a date, a timestamp, a log level, and then you have a message. Is this fun to work with afterwards? Because basically you will need to write a regular expression. Do you like writing regular expressions? If anybody says yes, it's probably Stockholm Syndrome. Or at least that's my opinion, because writing regular expressions is not one of my favorite things to do. What we do instead is we're kind of cheating. Luckily, Monolog can write out structured logs as well. So I'm just writing out JSON here. So you can see I have just one object for every message. And then you don't need to do any parsing, since Elasticsearch is storing JSON as well. My FileBeat can just take the JSON file, store it into Elasticsearch directly, and then we can work with that. So let's take a look at what we have here. So for this, we have discover. And in discover, I don't want metric beat. I want FileBeat. Unfortunately, this will contain a lot of information. We have almost 40,000 events here, because this includes system events like the SSH auth logs, it contains the Nginx events, it also contains the MySQL logs. So we want to filter that down. By the way, how do we efficiently filter that down? Just to show you, we've just seen that configuration here. Basically, I'm collecting the regular log file. This is how you would collect the regular log file. And then I'm also collecting here the JSON logs. So basically here, say this is JSON, and then I add one additional field to these events here, where I say, this is my SilverStripe application. And then you can very efficiently filter down for application SilverStripe. So what I want to do here is, by the way, is it readable for everybody? Let's make it slightly larger. So what I want to do here is, I have the field application is, and let's say we have multiple applications. I just want the information for the SilverStripe application. If I filter that, you can see suddenly we're down to 28 hits instead of 40,000. And then you can unfold that, and you can see Kibana now, this was a major feature in one of the recent versions. We now support emojis. So while they are broken or not nicely viewable in the log file, you can see the emojis properly in the log file here. So you can see, okay, you can see log levels, you can see various other kinds of information, so we're collecting all of what you have in the log file. In addition, we also enrich two kinds of information here. First, we have some host information. This is this part here, which can be very handy. So it basically shows you what is your operating system, what is the major version, what is the host name, what is the IP address. So you can filter down on that, or you can figure out like, okay, this error is just happening on this specific operating system. So we are automatically enriching all the events with that information. Secondly, since this is running on AWS, we also have this meta information here. And here you can basically see where is this running, which availability zone, which region, what is the instance ID, what kind of instance type do you have here, and then you can draw your conclusions from that as well, or filter down on the specific IP to figure out where is stuff even happening. Is it just one instance if you have multiple ones where bad stuff is happening, or is everything in trouble? And then you could start graphing out like how many errors do you have, or what is even going on in your system. So these are the logs. So let me quickly cheat and see, did I miss any main part we wanted to show? Oh yeah, something that might come in handy, by the way, which I should show you, is we have one more beat, or actually we have two more beats. Let's quickly go to them. First, we have heartbeat. Heartbeat is basically a pinger. It continuously pings your service and tells you A, is it up or down, and B, how quickly is it responding. We support ICMP, TCP, and HTTP, HTTPS. You can see here in the last 30 minutes, maybe something was down in my service. Maybe I have configured that wrongly. But it assumes something is down, which is surprising. I'm curious, what does it think is down? It thinks Kibana is down. Interesting. Let's switch that over to the last 15 minutes. Okay, it still thinks Kibana is down. Okay, I need to fix my pinger here, and it thought that my page was also down, maybe because you ran too many requests against that. But generally, what this is doing here, it shows you, okay, A, what is down, and B, how long did stuff take to respond. So here you can see how long did it take to resolve the service, how long did it take for the TCP handshake, establishing the HTTP connection, and establishing the TLS handshake. And you can basically see where did you spend your time as well. And then you can see, okay, something is happening and my service is responding more slowly. I'm actually confused why it thinks my Kibana is down. I will fix my configuration afterwards so you can have something to look at. The other thing that we are running is, that can also be quite nice, is we have something called AuditBeat, which basically looks for security events, which can be either AuditD, the Linux kernel messages, and we can also check for file integrity. So basically we see, did something change in my file system? Which can be very nice if somebody hacked your page and suddenly changed your files. You can actually figure out which user changed what files when. We don't have any changes here. Let's see in the last 24 hours, did we have any changes? So basically you can see here, this is when I deployed my application and I haven't changed it since then. But you can see files created, modified, deleted. You can see, okay, 1 file deleted, 3 modified. You can see which users were doing that. These are the users, and then basically you can see which were those files that were changed. So I'm basically monitoring my var www folder, because this is where my application is living, and there you can basically see everything that changed in there. So every time I redeploy my application and I change something there, you can see what is happening, like which user is doing that, when did it change, and what has changed. Because we're basically taking a hash of every single file in there, and then we compare them continuously and see, oh, something changed. Okay, let's see. One thing that we're currently working on is we want to add tracing to your application. So tracing can look something like this. This is for a JavaScript application. Basically, you can see here, this called this, and then it called this other thing. And with JavaScript, this is very easy. Basically, you can also see the code behind it. And if you link that to your GitHub account, you can even see who committed that code. And then you know who broke something or who committed some slow code. It can also look something like this. Here, this is a Python application. So basically, we are monitoring like which endpoints are you calling, what request type, the average response time, the 95th percentile, and then you can see, okay, which were the internal calls. This includes database calls, for example. So you can see if I request my starting page, what are the actual database calls I need to run to get the start page? Or can it all be served from a cache, and then we will show you from the cache. These are the ones that are supported by us. The one language that we're not supporting right now is unfortunately PHP. However, there are 2 agents from the community to do that. I think the better one is from Frank. He is living somewhere close to Amsterdam, I think in Haarlem. You need PHP 7.2 to run that one. And then there is another agent that also recently got some more attention again. I haven't tried them out yet. I should probably in the future. But this is basically to hook in your application and see from inside your application what are your requests doing and where are you spending your time. Yeah, to wrap up, I always compare this a bit to Lego. So you have all the building blocks, but you need to do some assembly. You have examples in my repository, but yeah, some putting together of the building blocks might be required. The nice thing is, since this is all pluggable, you can also include your business metrics. For example, if you have visitors on your website, you could include like how many people put something in the web shop in the basket, or how many people finished my web shop, or what is the revenue today, or how many people signed up for my newsletter. Since these are all custom metrics, you can just store them in Elasticsearch and then graph them out with everything else. And then you can see, oh, my site got slower, maybe people are buying fewer things now, and you can correlate those. If you want to try this out, there is dashboard. There you can play around with the dashboards, and all the code is available under that URL, which is mainly configurations and some Ansible and Terraform. Cool. Questions? Oh, by the way, I have some stickers up here, so if you want to have more stickers for your laptops, your children, sleeping coworkers, sleeping people at conferences, you can use them. Any questions? Yes, please. Could you show the GitHub? Sure.
Out of curiosity, what's like the minimum requirement for the Elasticsearch server? Like if I take a 10 euros a month server with 1 GB of RAM, is that enough to run?
So, Elasticsearch is a Java application, so it will need some memory. Generally, the The minimum setup for Elasticsearch itself that you will need is probably 1 GB. So we will give 1 GB to the heap, and half a gigabyte to the heap, and half a gigabyte for file system level caching. 1 GB instances are also the smallest container we offer, for example, for our cloud service. So that works. It doesn't provide you high availability because, well, one node cannot give you high availability. On the other hand, if your monitoring data is gone, how big of a deal is it? So yeah, for Elasticsearch, it's 1 GB the minimum. Then you will need, to run Kibana, that will need some other resources. So I would normally say if you have 2 GB of memory, I would give 1 GB, 1.5 GB, or more or less to Elasticsearch, and then the rest to Kibana. And that should work. So that would be kind of the minimal setup. The beats, obviously, you need to run on your own servers where they collect the information.
Yeah. Okay.
I hope that makes sense. Oh, by the way, I should take a picture with you so I can prove to my colleagues that I've been working today. Because they normally don't know where I am. I don't think they know where I am today. So you're hard to get into one picture. First, smile, everybody. Yeah, wave, wave, wave. So other side. Wave as well. Thank you. Thanks for the cooperation, so I can prove that I've been working. Any more questions? Yes, please. Right behind.
Well, it feels to me like you're kind of drowning in data. So can you give a feel of what kind of metrics you're using on a daily basis? And second, I suppose you can define all kinds of notification settings as to when to be notified when something is wrong or not.
So, notifications are easy, and I have good and bad news, kind of. Notifications are the way how we make money and pay my salary. If you're using our cloud service, the notifications are included in our cloud service. If you want to run it on-premise, we have like a commercial package for that. There are free open source alternatives to that, which you can also run with some technical drawbacks. We could discuss those as well. But generally, alerting is totally possible. So just to show you what alerting no, this is the wrong one, management. Alerting for us, we call that Watcher. And I should connect my phone back so it actually has internet. So there's something called Watcher. And what Watcher basically does is anything that you can define as an Elasticsearch query, you define then an interval how often you run that, and if a condition is met or not met, you can trigger an action, basically. So the idea is, actually I even have that in my slide deck. So Watcher might look something like this, the alerting. So here, this is like the heap usage or some memory usage. This is basically the baseline I set, and then you can see this is the usage pattern, and if it crosses that, I want to be alerted. You could do that for system is down, system takes too few requests, too many requests, too many database queries, whatever. So anything you can express as a query, we can run there. By the way, you can already see one of the problems here. If you have a threshold that is a flat line and you have a pattern like that, it's kind of very hard to find the right point where to alert. We have another commercial extensions for that that's also available on cloud, which is machine learning. Machine learning is unfortunately a very overloaded term, so this is basically anomaly detection of time series data. What basically means is we have this blue band here, which is the baseline that we expect, and this blue line here, this is the actual value that we have. And basically, once the actual value gets out of the expected range, it can alert you. And here you don't need to set a threshold, and you can also see these are the traffic patterns. So you can see this is the weekend, and then you have Monday, Tuesday, and Wednesday. So these are basically the peaks of what you expect on your site, because it's very hard to set these thresholds oftentimes. And also you don't want to invest so much time in setting all the thresholds. And you can see an anomaly there, like these red dots, these are anomalies. So this was a good year ago when Amazon had that S3 outage, and that is our own website. And unfortunately we had a dependency on that, and our own website dropped. But since the entire internet was pretty much down on that day, nobody cared. Which is always nice. Sorry, what was the first question? I think I only answered the second one now.
I was just wondering, you're drowning in data, like you have so many options. Can you give the top 3 metrics that are most important, or a feeling for that? So I mean, it depends on the application, of course, but...
my number one metric is availability of the service. Like I would define like, is my service responding? Yes, and B, how quickly is it responding? And once you have that, you can then drill into the data to see like, why is it responding slowly or why is it not responding at all? So I think that is kind of the most visible one because that's what the user is interested in as well. And if you have like good URLs, you could even ping various things on your website. So you could run, for example, a search query and see how quickly is my search query responding. Or you could trigger a post to put something in your web basket to see if that is working. I think this is like what is most relevant to the end user, and that will show you, okay, something broke now or something is slow. Otherwise, yes, you have a lot of metrics, but they will mostly come into play once you start digging because you know something is not working. Like just monitoring like how many people are visiting my website. Maybe you had an ad or something and suddenly more people are on your website. Do you want to get alerted for that? I don't know. Or you have a threshold like on a weekday we should have that many people on our website. Maybe it's a national holiday and you don't care that much. So yeah, like you said, you can collect all kinds of data. I think ideally you can like include what is seen by the end user and maybe some business metric as well. Like how much have we been selling today? And if that is not like the right number, maybe then you want to trigger an alert or have people signed up for our newsletter. And if not, then you might want to look like what is the performance or what are the errors and what is happening to my system. I think that's easier than just trying to set a threshold for every single element, like how many MySQL queries do we have, how quickly are they responding. That's nice, but not really relevant for the end user. That's more than to debug and find what is causing the trouble. I guess we're out of time.
Yes.
Yes.
Any other questions left here for the audience? There was one. Yes, Johannes?
I'm also here for the rest of the day, so if you have anything, just come to me afterwards as well.
Okay, going back to his question, so would you say that you use Kibana more for the analysis once something went wrong to do a drill down and figure out what's causing it instead of SSHing into every server and looking at log files?
So it depends a bit on your architecture as well. If you have more than 5 servers, SSH and tail is probably a pain in the ass.
Yeah.
And
yeah, but you don't use it as a dashboard that you look at all the time. You collect all these metrics so that you can then understand what's been happening when you have a problem?
I guess it depends a bit. Like, it's common to have like this big dashboard in your office and then you see, but these need to be like key metrics that are kind of actionable and are relevant for the people that have them. So for example, you might have one dashboard for the sales unit and one for the system administrators. And maybe the system administrators just want to see the latency or the network traffic or something like that because it makes sense to them. Yeah, in an ideal world, I think I want to be alerted for most of the stuff, and a lot of the stuff should be kind of like learned, or like you have the right threshold if you know that, and then you can take the right action. Like having everything on a dashboard, we always say you cannot have enough interns to stare at all the dashboards that you can build. Yeah, you can have them stare at dashboards, but that's not really what humans are really good at, like staring at things and like what should this curve look like. I don't think it's really the perfect thing. Thanks so much.
Okay. Thank you, Philip.